Okay, so I said Math.random produces a number between 0 and 1, but a lot of times you'll want to get a number that's not in the range from 0 to 1. So how can you do that? So let's say we wanted to generate a pseudorandom number from A to B instead. And I'll substitute this with concrete numbers in a moment. But what you do is you take Math.random and you multiply it by B minus A. Right? So what this is going to correspond to is stretching it, right? So it's stretching what you have initially. Math.random is producing a number from 0 to 1. So you have something that's of length 1, and by multiplying it by b minus a, you're going to get something that now has a length of b minus a, and this is going to be a random number from 0 to b minus a, right? If the original number produced were 1, now we said it can't actually produce 1, but if the original number were 1, then when you multiply that by b minus a, you're going to get b minus a, right? If it were 1/2, then when you multiply that by b minus a, you're going to get 1/2 b minus a. So it's going to be the midpoint here, right? And then the next step is to add a. So that's going to shift the interval by a. So if you were originally getting a number from 0 to b minus a, now you're going to get a number from 0 plus a, which is a, to b minus a plus a, which is b. So let's just give an example with numbers here. If a is -1 and b is 2, so you want to get a pseudo-random number between -1 and 2, first you do 2 minus -1 to get 3, right? That's your b minus a. That's the length of the interval from -1 to 2. And you're going to take that number and multiply Math.random by it, right? So now you had a number from 0 to 1. Math.random gave you a number from 0 to 1, and by multiplying it by 3, you're now going to get a number between 0 and 3. Okay, and the next step was to add your a, right? So to add your -1. So that's really just subtracting 1. So what that's going to do is it's going to shift everything left by 1, right? So if it were positive, it shifts it right. If it's negative, it shifts it left. So rather than getting a number from 0 to 3, when you subtract 1, you're going to get a number from -1 to 3 minus 1, or 2, which is exactly what you wanted. So just to see this pictorially, right, we have our number from 0 to 1. When we multiply by 3, that stretches it out, right? 0 goes to 0, 1 would go to 3. Again, we don't actually get 1, which is why we have that open circle there. But we could get anything in between. So if we had 1/2, right? 1/2 when we multiply by 3 would go to 3/2, or 1.5. If you had 1/3 when you multiply by 3, you would get 1. Okay, so now we have a number between 0 and 3, and we subtract 1. That shifts everything left by 1, right? The 0 would go to -1, and the 3 would go to 2. Okay, well, what if we wanted to generate pseudo-random integers in the range? So, right, so before we could get any number between, let's say, 0 and 1, and we changed it to get a number between -1 and 2, but what if we instead wanted to get only integers, so integers being 0, 1, 2, 3, etc., and also possibly negative ones like -1, -2, -3, etc. So to be completely general, let's say we want to get integer outcomes from a to b minus 1, right? So as an example, if a were, let's say, -1, right, and b were 1, we would actually be using b of 2, right? So it would be 2 minus 1 to get 1, right? And the trick would be here to, again, multiply by b minus a, and this is going to stretch the length of the interval to have a length of b minus a. And b minus a is the number of possibilities from a to b minus 1. So just as an example, again, the number of possibilities from -1 to 2 minus 1, right, is the difference of those numbers, 2 and -1, which is 3. And the reason is because it's not just, well, the reason why it's b minus 1 and not b here is because you're actually including both the starting number and the ending number. So for example here, you say negative 1 to 1, the distance between those is only 2. That just means that you go over 2 places to get from negative 1 to 1. But as you can see, that means you're only counting the 0 and the 1. You're not actually also counting the negative 1, right? So to also include the negative 1, we were going from a to b minus 1. We multiply instead by b minus a instead of b minus 1 minus a, right? So once we actually have stretched it, right, just like before, we're going to be adding a. This will give us a number between a and b, right? So before we get a number between 0 and b minus a, and then once we add a, we get a number from a to b, right? So that's just like before. But now what do we do to the result? We do math.floor of that. So math.floor is going to round down to the greatest integer that's greater than or equal to the input. So what I mean by that is like math.floor of 3.75, right, gets rounded down to 3. 3 is the greatest integer that's less than or equal to 3.75. But if you take negative 3.25, that's going to get rounded down to negative 4, not negative 3, like math.trunc would do, which is just remove everything that comes after the decimal place, right? So it goes to the greatest integer that's less than or equal to negative 3.25, which is negative 4. But the point is, when you do math.floor, you're getting an integer. So again, going back to the specific example where your b is 2, right? Because you have b minus 1 is going to be 1, which means b has to be 2. You're going to multiply by the b minus a, right, which is going to be the 2 minus negative 1, which is going to be 3. So you're going to do before, like as you did before, 3 times math.random, which is going to give you an interval of length 3 from 0 to 3. And as before, you'll also add negative 1, right, which is your a, to get a number between negative 1 and 2. And now taking that result of 3 times math.random minus 1, using math.floor on the result of this, right, so making the 3 times math.random minus 1 the input to math.floor, is going to give you the possible numbers of negative 1, 0, 1, right? So negative 1 to 0, not including 0, will get rounded down to negative 1. 0 to 1, not including 1, will get rounded down to 0. And 1 to 2, not including 2, which is not even a possible result, gets rounded down to 1. Right, so we could again see this pictorially, right? Last time we had done 3 times math.random minus 1, so we get the number from negative 1 to 2. And as I mentioned, when you do math.floor of this, anything between negative 1 and 0 will give you negative 1. Anything between 0 and 1 will give you 0. And anything between 1 and 2 will drop down to give you 1. Right? So of course 0 will still give you 0, negative 1 will still give you negative 1, and it's impossible to get out 1. Right? So in general, you should just multiply by the number of possibilities, the number of possible integers that you want, subtract or add depending on what you want the starting number to be, and then use math.floor on the result. Okay, well, I said about using math.random to simulate experiments, and sometimes you do want to produce numbers between let's say negative 1 and 1, as you did for the throwing darts example, to get x and y coordinates. And another one, you might want to simulate the roll of a die, in which case you only want to produce integers from 1 to 6, right? You want to get 1, 2, 3, 4, 5, and 6. So the previous example that I gave you would give you an idea of how to do that. But another thing you might want to do is, like we had for the roulette game, you'll want to simulate something that has a certain probability. So for instance, let's say you have something that has probability of 1/4, and you want to know if it occurs or not, right? We had something like that in the rains 1 week from now, right? We were asking what's the probability that it rains 1 week from now, and you had to simulate whether it rained or didn't rain the next day, which had probabilities of 0.3 or 0.4, depending on whether it rained today or not. So you wanted to simulate whether the next day was going to have rain or not based on these probabilities. So if you have the probability of something happening that's 1/4, right? One way to do this, to actually simulate whether this occurs or not, is to use Math.random. And remember, Math.random is producing a number between 0 and 1. And then you can ask if that's less than 1/4. So what's the probability that that's going to be less than 1/4? Well, that's 1/4 of your interval. And since each number is equally likely to be produced, the probability of that happening is 1/4. And so if you want the probability that it doesn't happen, it's the remaining 3/4, right? So by checking if Math.random is less than 1/4, you can basically say, did this outcome with probability 1/4 happen? And if this is true, then it did. And if it's false, then it didn't. Right? So this should be able to help you with those problems that you had, like rains 1 week from now. But the other thing I want to mention is that regardless of whether you use less than or equal to, it won't matter. And that's because the probability of getting 1/4 exactly is 0. Now, technically, it's not 0 because the computer is incapable of producing every possible real number, but it's just so small that you could basically consider it 0. So whether you use Math.random less than 1/4 or Math.random is less than or equal to 1/4, either way is fine for simulating something that has a probability of 1/4.